If I do that, what would have to go here? 1 minus. Now you have to think about this a little bit. 3 halves. X to the 3 halves. Why? This is really x to the half, right? And if you multiply that here, you add a half plus 3 halves and get 4 halves, that's 2, right? So do y'all see that this is this? And now this goes where? Where's x going? Infinity times 1 minus, and that goes to infinity. So where does that go? Negative infinity. But now it's times what? Positive infinity. And that's going to be a huge number. It's going to be negative because one's negative, the other one's positive. So your answer is negative infinity. Go ahead. All right. And then these are limits where you get something like fixed over 0. Fixed over 0. That's like the quiz today. This, I believe, is, I don't even know. Fixed over 0, yeah, fixed over 0. I gave you a lot to practice. I told you to skip number 21. Pardon?
It is 4 pages.
Yes. 21, don't do, right? 22, I did in class, right? I showed you something like that. In fact, the one I showed you didn't even have an interval. This is the one that has to do with continuity, where you have to show that it changes signs. All right. All right, find the equation. We're almost out of time. Find the equation. Find the equation, find the equation, find the equation, right? All those problems of the tangent line, of the tangent line. And you have to use a limit definition for these. So you have to use a good old-fashioned limit definition. Find the derivative of this. I give you a point. You come up with the equation of the tangent line. So work through those. Let's see. These are all derivatives. F prime of A, here they are, using the limit definition. This is like torture. And then we did that problem, right? We did this one earlier. That one, using the limit definition, bad. We did those. And now these are all using the rules. So no more limit definition. So could you do the derivative of this? Yeah, this is all just powers. These are all powers of x, right? So you rewrite them as powers of x and just do the power rule. This one is just like the one we just did, right? Where you have to split it up. Oh, I didn't show you the second way of doing it. It's okay, I'll just show it to you on this one. Instead of bringing this x squared up, the way that I like to do it is I like to do that over that, that over that, that over that. I split it into 3 fractions instead. And then I simplify each fraction and then take derivatives of those. It winds up being exactly the same answer. So like if I were doing this, I would do x cubed over x squared plus 2x over x squared minus root x over x squared. And then this becomes x. This becomes 2x to the negative 1 because the x's cancel. You have an x left on the bottom. I bring it up. And then here I subtract. So I get x to the negative 3 halves there. And then I take the derivative. Either way works, but I just want to show you the other way. Look at the last one, number 32. Find the equation of the tangent line. We did those earlier. But see, now you can use the shortcuts. So you can just take derivative of this. And I give you the point. All right, we have 5 minutes. If you're happy, then you're free to go. If you have any questions, stay behind. Do we have any questions? We know what we're doing on Tuesday, right? Coming in and taking the test. All right. Right, yeah, they're right there.
where we saw wallpaper,
Mm-hmm.
like the